Hi all, myself Sainath Nekkanti, and today I'm going to explain you all about my database systems project. And coming to my project title, it's known as Blood Bank Management System. Coming to the abstract, Blood Bank Management System is intent. By this application, I'm trying to automate the blood bank activities such as identification of donors, supplying blood to the hospitals whenever necessary, and maintaining details of all the blood groups that were available in that particular blood bank. It's like a database that stores all the information and it helps to the intended people whenever they require it. And through this data application or data frame, it also helps the blood bank managers to provide all the information of current availability of each sample and the list of all the donors that already visited their branch in case of any emergencies. And using this data, we can build n type of reports, including stock reports, donor gender reports. Using this, we can be able to identify the right donors at the right place whenever there is no immediate availability of all the blood resources. And using this, we can come to know the trends of all the historic data of what is actually required. And coming to the introduction, a blood bank, basically the term blood bank actually refers to the collection of blood and that's stored in usually bags. And this is all handover or this is all carried out through a medical laboratory where all these are stored, and this common terminology is known as a blood bank. Using this application or this data frame, we can easily identify the donors, the process of finding the trustworthy donors, basically who are willing to donate their blood in case of any emergencies required situations, and keeping an eye on requirements is difficult. The major objective of this project is to maintain the information of all the hospitals, available blood bank branches and samples and stocks and requests and list of all the available donors. And in this project, I'm also considering an employee who is basically maintaining the particular blood bank. The reason why I have opted this because there are no other ways of generating blood in any other ways other than finding a right donor or collecting blood through any donations. And using this data frame, we will be able to sort all those details or club all those details and keep it in a single frame so that it makes the life of the manager or the people finding it at the right time with simple ease. And coming to the operational scenarios, using this DB, I am trying to create new donors. If someone is willing to donate the blood in a particular branch, we will be creating a donor. And if there are, and also updating existing donor information. The sample use case is the last donation date. Let us say that if I'm willing to donate the blood and that my last donation date will be today. It means that keeping the donor information up to date so that we can be able to reach out to them in case of emergencies whenever their donation dates crosses our criteria, like let's say 6 months from the date of donation or 3 months. Such donors of suitable blood groups and contact them if needed. As I mentioned earlier, if there is no immediate availability of that blood, we can identify the right donors using the data that we have currently in the system. Request from blood from one branch to another branch. If there is a blood sample that is already available in one nearest branch and shifting that to the branch that is actually requiring that blood, that's kind of operations. List of all the available blood types and sorting of all those things on the donor list, or all those things can be done using this. And using this data, we can also track the blood requests of what are the existing blood requests that are already served and which are actually pending for fulfillment, or which are actually waiting for someone to collect those samples. And manage employee information, basically who are owning or who are driving the complete blood bank operations. And the donor list, basically the list of people who are actually donating, and those. Using all this information, if it's connected to any external reporting tools like Snowflake or all other things, we can drive the results and trend it. Basically, we can come to know or what is actually required, and all those things. We can come to some conclusion looking into the data. And coming to this project, I have implemented this considering 3 plus 4 total 7 tables that are nothing but entities, and one of the entities branch, employee, donor, blood sample, blood request, person, and hospital. And each one of the entity has a primary key which is unique to the table, and that unique table and that primary key is referenced as foreign key in another table. That's how we connect the both of the tables. And coming to the branch table, bre_id, that is nothing but the branch ID, which is a unique. And coming to the employee table, it's employee ID. And coming to the donor table, it's donor ID. Coming to blood sample, it's blood sample ID. For blood request table, it's blood request ID. For person table, it's person ID. And coming to hospital table, it's hospital ID. Along with this, I'm also maintaining some useful information like branch name, address, phone, email. And coming to employee, the name of the employee, salary of the employee, role, address, and the branch ID he is associated with. Actually, the branch that he is currently employed with. And coming to the donor table, I am considered along with the unique primary key, I have considered name of the donor, gender, phone number, address, blood group, and the last donation date. Basically, the last time I have created this attribute to actually maintain the date that he has donated at the last time. Blood sample ID, which is a unique number, and blood group, the actual blood group, and quantity, how much it is available on the donor who gave it or who donated it. Coming to blood request, it's the blood group, blood quantity, ID. And coming to the person here, person is nothing but the individual who is requesting the blood. And coming to this here, I'm collecting the details like name, address, gender, phone number, and the request ID that he has raised, so that I can combine these two tables using joins. And coming to the hospital tables, I'm maintaining ID, name, address, zip code, and the blood request ID. In my use case, the blood request can be raised either by a person, that is nothing but an individual, or by an hospital. And this is how I draw my entity relationship diagram. Using this, we will come to know the relationships that are available between the tables. Here, coming to the branch and donor table, that is how I connected using a M:2N relationship. One branch can have any number of donors, and one donor can donate his blood or to any of the branches. And coming to the branch and employee table, I have connected it to 1:M. That is keeping something in mind, like one branch can have n number of employees, and one employee can be associated with only one branch. And coming to the relationship between the donor and the blood sample, basically I have connected it using 1:M relationship. It means that one donor can give any number of blood samples, but one blood sample can be of only one donor. And coming to the branch and blood request, this is how I connected using a M:2N relationship. In the next slide, I explained in detail of all these individual attributes, but looking into this ER diagram, I am denoting these things. And coming to branch and blood request table, I have connected using a M:2N relationship. It means that one branch can get any number of blood requests, and one blood request can be raised to any number of branches. And now coming to the relationship between blood request and person, it's like a 1:M relationship. One blood request can be either part of one person or one hospital. It means that one blood request can be raised by n number of M persons can raise one blood request, and one blood request can be of either one person or hospitals. The same applies to hospitals as well. One blood request can be raised by one hospital, and one hospital can raise any number of blood requests. And coming to this, I have sliced or breakdown into individual entity relationships. And coming to the for present current use case, it's one-to-many binary relationship. And coming to the tables or the entities here, I have considered employee and the branch. And this is how I connected using a 1:M relationship. A branch contains minimum of one employee, and maximum of any employees can be associated. A branch contains minimum of one employee, a minimum of one employee of maximum of any employees. Basically, a branch can contain any number of employees, and one employee can only be associated with one branch. And coming to the donor versus blood sample, a donor can give or donate minimum of one sample. Basically, he or she can donate a blood sample, and any one blood sample can be only given by one donor. Basically, one donor can give minimum of one sample and maximum of any number of samples, and one blood sample can only be belonging to one donor. And coming to the relationship between blood request and person, a blood request can be raised by any number of persons with a minimum of one person, and m persons can raise one single blood request. And coming to the relationship between blood request and hospital, a blood request can be requested by minimum of one hospital. Basically, a blood request can be raised by any number of hospitals with a minimum of one hospital, and m number of hospital can request one single blood request, and m requests, basically multiple things can be requested by multiple hospitals can be requested by blood request. And continuation to it, this is called as many to many binary relationship. And here the tables I have considered are the branch and donor. Basically, a branch can have minimum of one donor to maximum of any number of donors. And coming to this, a donor can go to maximum of any number of branches with a minimum of one branch. Basically, he or she can donate it by going it to any of the available branch. And now coming to the branch and the blood request, one branch can have minimum of one blood request. Basically, it's a one blood request and maximum of any blood request. And one blood request can be part of minimum of one branch and maximum of n branches. It means that one branch can raise n number of blood requests, and one blood request can be part of any number of branches. And coming to the normalization rules, and that is applied to the tables. Basically, normalization is a step-by-step decomposition of larger relationship into the smaller relations to reduce and avoid the anomalies. Basically, here I consider till 3NF, that is first normalization form, second normalization form, and third normalization form. These, and in the next slide, I have applied these normalization rules to my tables and made sure that all my tables are satisfying till third normalization form. And coming to this branch as branch ID, from there using the branch ID, I can strictly derive the values of name, address, and phone. And coming to the employee table, by using employee ID, I can denote the name, salary, role, address, and the branch ID. And coming to the donor, using the donor ID, I can denote name, gender, phone, address, blood group, and last donation date. Blood sample table, using blood sample ID, I can denote the blood group, quantity, and the donor ID who donated it. Coming to blood request, using the blood request, I can derive the blood group, quantity, and branch ID. And person, it's nothing but the individual or the requester. Using his ID, his or her ID, I can derive the name, address, gender, phone, and the blood request ID. Hospital, coming to the hospital table, using the hospital ID, I can determine the name, address, and zip, and the blood request ID that they are going to raise or that they have raised already for request the blood. In all these above relationship, all the attributes are atomic, which means invisible. So they satisfy the first normalization form. And here, every non-prime attribute which are on the right side are completely dependent on the primary key. So they also satisfy that second normal form. And coming to the third normal form, as we can clearly, looking into this, we can clearly determine that there is no transitive dependency between the non-prime attributes which are on the left to the primary key attribute which is on the left. So it also satisfies the third normalization form. This is how I applied all the normalization form that were required, that is 1, 2, and 3 on my tables, and made sure that all my tables are satisfying those things. And coming to the SQL queries, here are the sample syntaxes or the sample things that I have already placed it. And for suppose, as in my project, I have considered 7 entities or the 7 tables. Basically, this is the table syntax or the SQL syntax for creating all these things. And first coming to the table creation, basically this is the syntax that's create table and whatever the table name that we are going to denote. And coming, these are the list of attributes or the columns that we are going to create in that particular table. Here table underscore name denotes it's a dynamic thing, and we can replace it with the table name. And coming to the columns, we can replace with all the columns that we are going to create in that particular thing. And coming to the syntax for the record insertion, once the table is created, we should be filling those the required details into these tables. Using this insert statement, we can insert records into the table. Insert into table name. Basically, this is the table that we are going to insert, and list. These are the list of all the available columns in the table name. And coming to the values, and these are the respective values that we are going to pass for each of the particular column. Basically, value 1 goes to column 1, value 2 goes to column 2, and value 3 goes to column 3, and it continues to so on. Syntax for view records, and this is the third phase where someone wants to view what's currently in those tables. Basically, this is called as select star from table name, table underscore name. Basically, this will be replaced with the table name. And this is the syntax to view all the records in the table. But if you want any particular records or anything, we can write a where statement and we can filter out the details. And I have taken one example. Basically, this is the table syntax I have used. Using the previous syntax, I have created a table called branch. Here, if you see, create table branch. Here, branch is my table name, BID, and this is the data type I have given integer, and these are the list of other attributes: B name, B address, B phone, B email. And for rest of the things, I have given the data type as varchar with a maximum size of 20, 40, 20, 20. And I have also included a attribute called as not null, which means that I'm expecting some value for each and every record in these columns. And using the primary key, I have denoted this B underscore ID as the primary key. And this is the screenshot of the sample summary of the table that I have taken after creating it. And coming to the branch table, insert into records. Basically, this is the table, insert into branch. And these are the list of available columns in the branch table. That is branch BID, B name, B address, B phone, B email. And these are the sample records, 10 records I inserted into this. Basically, these each column and each value, this gets inserted. And coming to how to view these records, basically, this is the statement that I have used to view the records. That is select star from branch. Basically, these are the list of available columns: BID, B name, address, phone, and email. And these are the list of available records in that table. By using this command, we will be getting to know. And taking a break here, I just want to take you to the SQL workbench. For this records insertions and all, I have used a SQL workbench in my project. And for this, I have created a sample project called DBMS project. And when I used it to make use of, and these are the list of sample commands I have executed. Basically, whatever the thing I have mentioned it in the deck, the same gets applied. And if you wanted to see the description, this is basically the summary that we get after creating a table. This is the thing that you need to execute to see the corresponding output. And this is the thing that we can see. And now let us view the records that has been inserted into the branch table. And this is the same process that I have repeated for all the 7 entities or the tables that we have. Basically, first I mentioned the create statement through which I created a table. That's nothing but the structure, and followed by the insert statement where I have inserted records into the table, and followed by the select statement to view the records of that particular table. This is how I will be able to view the results. And the same thing gets applied to rest of all the tables as well, rest of all the things as well. And coming to the future scope of this, I'm trying to given a chance, we can build a GUI based application that can be developed using this data or this frame, which basically connects all the users by hospitals with various blood banks in the city. By looking into the data into the blood branches table, we can get to know what are all the list of things that is available, and using a front-end application, we can present it very well to the users. And these applications can also be installed in ambulances to save time. This is nothing but whenever there is someone in emergency of blood, there is no requirement or purpose for ambulances to go and stick around multiple things. But using this data, they can come to know where and what quantity is exactly available in those things, and developing a donor application. Basically, this is a second application that we can build, which basically notify all the donors using SMS or some email things, which we are not currently maintaining the email, but if in future we can extend the column who are eligible to donate blood, and this can be derived using the last donation date, and in such a way that we can provide or we can give awareness among the public so that they will be donating blood whenever required. And coming to the project, as I mentioned, that the goal of this project, or the main idea I choose in this topic, is to build a platform where they can store data about the donors and the branches and the hospitals that are raising way, so that it can be centralized and it can be easily accessible by anyone who required it and the required point of time. And as I mentioned in the previous slide, this can be expanded upon by creating an application to submit all those requests and all, which actually denotes the things where and how much quantity of blood is available in all these things. And that's about it from my end. So these are all the things that I have implemented as part of this project. And thank you for giving me opportunity to be part of this project. Thank you.